Hello everyone, in this video, this is the third video of this problem. This is the third part. And for the last part, we're going to find for the value of the integral from 0 to 2 fx dx, or show that it diverges for k is equal to 1. And we're going to consider the family of functions fx is equal to 1 divided by x squared minus 2x plus k when k is a constant. Okay, so the first thing we're going to do is, take the integral from 0 to 2 of fx, which is 1 divided by x squared minus 2x and plus k, and we're going to replace k with 1. Plus 1. And also, we can factor this. We can factor the denominator. And if we do factor it, we have 1 divided by x minus 1 squared dx. And you would probably think that we can just integral this, right? We can just rewrite this as x minus 1 to the power of negative 2. And then if we integral it, we would have negative 1 over x minus 1, just this, and then we would just put in the 0 of 2. But this is not that simple because this problem actually diverges. And I'll show you guys why. As you can see, if we put in x is equal to 1 into this function, then we would get 1 over 0, which is in infinity. It does not exist. So we have to break this up into two parts. The integral from 0 to 1 of 1 divided by x minus 1 squared dx, and add that by the integral from 1 to 2 of 1 divided by x minus 1 squared dx. And as you can see, we still have the 1 here, and if we put in the 1 here after we integral it, we'll get 1 over 0, which does not exist. And so what we're going to do is use limits. We're going to take the limit as b approaches 1, and this will be from the negative side. And if we take the limit as b approaches 1 for this integral later, it will be from the positive side. The limit as b approaches 1 from the negative, so from the left side of the integral from 0 to b of 1 divided by x minus 1 squared dx. Add this by the limit as b approaches 1 from the positive side of the integral from b to 2 of 1 divided by x minus 1 squared dx. And so now let's take the integral of 1 divided by x minus 1 squared. If we take the integral, we have the limit as b approaches 1 from the negative side of negative 1 over x minus 1 from 0 to b, added by the limit as b approaches 1 from the positive side of negative 1 over x minus 1 from b to 2. Okay, now we can put in our interval or our x values. If we put in the b, we just have we're going to keep the limit, of course. If we put in the b, we just have negative 1 over b minus 1, and then minus minus, so positive. If we put in the 0, we have 1 over negative 1, so that's negative again, negative 1. Added by the limit as b approaches 1 from the positive side of, put in the 2 for x, and we have negative 1. If we put in the b, we have negative negative, so plus 1 divided by b minus 1. So then we're going to put the value of b that approaches to. Since for this one, the value of b, since b approaches to 1 from the negative side, we're going to just say that, substitute b as like 0.9. And that's pretty close to 1, and it's from the negative side. So it would have negative 1 over b, which is 0.9, approximately 0.9, minus 1 plus, since we have the limit as b approaches 1 from the positive side, we're going to, instead of putting just 1 for b, we're going to put in 1.1 plus 1 over 1.1 minus 1. As you can see, if we do 0.9 minus 1, we have negative 0.1. But since we have the negative here again, we would just have, I'm just going to write it here. I can't remember all of that. So 0.9 minus 1 is negative 0.1. But since we have the negative there too, we just have positive 1 divided by 0.1 minus 1. Added by, well, actually, I'm going to combine these two negative 1 values. So that way we don't also need the parentheses anymore. We would have negative 2, and then plus, if we do 1.1 minus 1, we just have 0.1. And we only approximated our b values, and if we hadn't, and we had instead of putting like 0.99999 repeating and 1.1111 repeating, then we would have gotten like a value that is a lot closer to 0, and the same for here. And what is 1 divided by 0? It's infinity, right? So that's infinity, and this is also infinity. And infinity minus 2 plus infinity is infinity. And since we got infinity instead of an actual value, if we take this integral, it does not exist. It does not exist. Or at the same time, we could write the answer as the integral diverges. So there's not really an answer to this problem. It just does not exist. So I hope you have a great day, and thank you for watching. This is the last part of this problem. Bye.